everybody. Welcome back to our final session. We're appreciative of you being here, and we appreciate our organizers. Thank you, everyone. And so this is my personal favorite session, as we're talking about remote sensing. Woohoo! Energy and climate data. So we kind of give an overview of, we're looking at the combination of remote sensing data availability as its analytical role and tools, and we're looking at how we can increase that as it relates to energy systems. So we have three great speakers here today, and I won't belabor the point, and I'll get right into it. Our first speaker is Angel Hugh, or Shu, yeah. She's assistant professor at the University of North Carolina, Chapel Hill, in the Environment and Ecology and in Energy program. So without further ado,
all right,
take it away.
Thanks so much, Joseph, and thanks so much to Kyle and Brian and Trey for inviting me here, even though I teach at the other school. So it's really been an incredibly invigorating and energizing, pun intended, couple days just hearing about all of the data applications and innovations with respect to energy and climate. So my work is really at the intersection of data science and environmental policy and decision making. And I'm just thinking back to a remark that Johannes made yesterday. I guess he stepped out. But he was talking about how if we are approaching these data-driven solutions to manage the energy grid or to better serve customers, then we have to really think about the end users in mind. And so that's really where my research is starting, is really from the end user and from policymakers and decision makers, and how in the face of the big data revolution and now AI, we can really try to tailor and seek that signal from all of the messy, noisy data to decision makers. So and most of my work is focused actually at the intersection of cities and focused on subnational governments. And so I have this illustration here just illustrating some of these interconnections between climate change and our energy system. So cities, through the consumption of electricity, are generating greenhouse gas emissions, air pollution, both PM 2.5 and NOx emissions. They're centers of economic productivity and output, so GDP growth centers, and also densely co-locate people within their boundaries. They also produce heat, so they're hotter than rural areas. And then I just put a little image from Catherine Burley, who is one of the fellows here. She's looking at electricity equity and they're in restoration after power outages. So cities are also more vulnerable than non-urban areas when it comes to climate change impacts, which we haven't discussed as much, and so I want to definitely touch upon that. So I have a very limited amount of time, and so I just want to bring three examples from my own work to talk about how we're using remote sensing and machine learning AI applications at this intersection of data and also climate policy. So the first example is how we're using machine learning and remote sensing data to predict emissions and mitigation performance, particularly on cities. And so if you follow the global climate negotiations, Antonio Guterres, who was the Secretary General a couple years ago at COP26, said enough of treating nature like a toilet. And a couple of people yesterday also mentioned the problem with greenwashing. So a lot of my work is looking at the role of cities as climate actors, and also the role of private businesses and firms in contributing their own mitigation actions to help narrow the gap between what national governments have pledged and where the climate scenarios say we have to go in order to close that gap. And so he convened this high-level expert panel to talk about how we can make subnational and non-state actors more accountable for the largely voluntary commitments that they make. And we just are finishing this global stocktake process because the whole Paris Agreement is predicated on people contributing data and being transparent about their actions. It's not this top-down compliance-based mechanism. It's really about users and governments and companies contributing data saying, this is what I'm doing to meet my climate change goals. And this is maybe hard to see, but this is from the Global Stocktake Synthesis Report that was just released a few months ago. And I was shocked because the first page is actually all focused on subnational and non-state actors. It says we need credible, accountable, and transparent actions by non-party stakeholders to strengthen systems transformation. So this right here, even before they talked about national governments, they're actually squarely talking about the need to enhance credibility of non-state actors. But this is problematic because this is from one of our databases where we've actually collected data on all subnational governments that are participating in international climate initiatives. So you may have heard of C40 Cities for Climate Action, or the We Are Still In movement, or Global Covenant of Climate and Energy Mayors. So there are more than 12,000, actually today probably more than this, that are actually pledging climate action. But less than 10% of them have actually reported emissions inventories. So that's incredibly appalling if we want to know, are they actually following through? Are they credible in what they're pledging, or is it just all a greenwashing exercise? And at the same time, I was on this National Academy of Sciences committee that was convened last year, where 11 experts, including myself, were asked to look at the state of greenhouse gas emissions data that's available and techniques such as satellite remote sensing or climate traces activity-based approaches. And you can read the conclusions. We said more granular, temporal, and spatial scale data with source level detail is needed to help cities, states, and provinces to manage their emissions. And in particular, the section that I led was talking about hybrid approaches. So realizing, and someone else said this on the previous panel too, about realizing that now there is not just remote sensing data alone, but the fact that we have AI, we have machine learning that can help us really take advantage and detect these non-obvious signals, like in your case, the plumes and how often power plants are running. Try to look at some of these more non-obvious signals to actually predict on the thing that we want to measure, which is greenhouse gas emissions, and to fill these gaps. And so that's exactly what we're doing. So we're taking geospatial data, remote sensing, satellite data on weather and fossil fuel-based emissions, air pollution as proxies for transit emissions, GDP as measured through nighttime lights, as well as population. And then we're training machine learning models to predict then cities' climate change trajectory, or I guess their climate emissions. But then you can see, this is probably a little hard to see here. So we can actually get annual signatures. So this is from around 2010 all the way to 2018. So you can see that we can actually we can predict on annual emissions based on the underlying annual predictors of fossil fuel CO2 emissions, air pollution I mentioned, GDP, heating degree days. And so actually get a sense of how cities are actually performing in terms of their goals. Are they reducing emissions? Are they staying flat like this one city in Belgium? Or are they actually implementing significant action like London here to really reduce their emissions? And so then you can start to make some comparisons to say and ask questions that are policy relevant and say, well, is participation in this one transnational initiative that's providing capacity and that's actually pressuring the cities to report on their emissions and helping them articulate these sustainable energy plans, is that actually effective in helping to reduce emissions and fill in global gaps in implementation and action? So what we found in comparing cities that participate on the left and those that don't participate is that 74% of the cities on the left who are participating are much more likely to have actually reduced their emissions compared to other cities that haven't. And so you're probably saying things like, if you're an economist, you're probably saying, well, what about endogeneity? And how can we actually establish causality? Because cities may be self-selecting into these networks, and those might be the front runners of climate action to begin with. And you're absolutely right. So we can't solve all these problems of causality, but we can look at some interesting patterns. And so what we found in this regression table is that we see that cities that tend to report on their emissions, if they're actually reporting their baseline emissions and their inventory emissions, then they're much more likely to have reduced emissions and much more compared to other cities that have not been reporting. So these are one of these proxies or indicators of implementation or success that could suggest that cities are actually meeting their goals. And this is really critical to help us identify some of these proxies in terms of whether or not greenwashing is actually happening. Okay, so the second case is how we can use machine learning and remote sensing data to estimate cities' exposure and vulnerability to climate change impacts and hazards. And so this data probably is familiar to most everybody in the room, but this is monthly temperature anomaly data compared to a 1900 to 2000 baseline. And so the zero line here is basically our baseline, and you can see all these years, 1971, so my parents probably remembered a lot of these years, 1951, cooler than average in these months. But really, 19 of the 20 last years have been the hottest on record, with 2016 being the hottest until just this past year, where we can see that summertime temperatures during June and July, August reach a new peak. And so I've been studying heat for many years, and it's been really difficult to get it on the policymakers' agenda because in the US, it's not classified as a disaster under the Stafford Act. And so finally, I'm hoping that this is going to bring more attention. I mean, unfortunately, because temperatures have gotten so much hotter. I mean, I was shocked going outside. It was like 80-something degrees. And then, of course, if you just Google, you probably came across a lot of these different headlines of record-breaking temperatures in Phoenix, Memphis, Houston, continuing to shatter records as July and September were the hottest months on record. I think, Morgan, you also mentioned that in your beginning remarks. And cities in particular are vulnerable because of the urban heat island effect. They tend to be much hotter compared to their rural surroundings. So these are the temperature signatures at the day and night because of impervious surfaces and the fact that they're more built up. They have a tendency to have less tree cover and more forested areas. And then we know that cities are not equal in terms of their development and their urban form. And so this is a picture from Johnny Miller, who does these amazing aerial photographs. So this is Mexico City, and you can just see this much wealthier neighborhood on the right with these amazing trees and these really nice athletic facilities, in direct contrast, just separated by a thin road from this much less wealthy neighborhood on the left. So people are not living unidimensionally within cities. And so in our Urban Environment and Social Inclusion Index, we've been using satellite remote sensing data to measure neighborhood differences in access to environmental amenities like tree cover, and also exposure to environmental hazards like air pollution and urban heat island. And the differences that we've found have been really stark. This is Los Angeles. And here on the left, you can see these much wealthier neighborhoods. I think this is Santa Monica. Average income of over $90,000 per year per person. And then also 70% tree cover here. But then these much less wealthy neighborhoods, only $30,000 per person, that translates to 5% tree cover. So huge disparities that we've been able to measure through this data. In the US context, we've also extended this analysis to look at intersectionality with race and ethnicity, and also income and age. And Los Angeles, I think anecdotally, we probably know about environmental racism and environmental injustice. But when we did this study, extending remote sensing and satellite data to cover every major urban area in the United States, the results, frankly, to me, were really shocking. So in 97% of major US cities, they are burdening communities of color with higher exposure to heat, almost a full degree Celsius compared to their non-Hispanic white counterparts. And I think what's particularly troubling to me is that the effect is most pronounced here in the Northeast, where I lived for 11 years. These are cities that are much older in terms of their development, probably a lot less able to implement new green space or tree cover, and also, frankly, where there's a lot less, fewer households with air conditioning. I mean, I lived in a place that didn't have air conditioning when I was a student in New Haven. One of the things that we realized with remote sensing, and this is one of the many limitations, Kyle, that you mentioned, is that often it doesn't precisely measure the exact problem that we are trying to assess. And so one of the things that we're doing is we're combining machine learning and also individual scale data. So that was also in the previous panel, they talked about combining different data sources. So when I first landed here in Chapel Hill, immediately got connected with folks in the Durham County and also city of Raleigh to do participatory heat mapping. So we sent out a lot of people with mobile monitors, sensors on cars, bicycles, and then I bribed a lot of my students to take these handheld sensors and did heat mapping in particularly vulnerable and exposed neighborhoods throughout Chapel Hill, Durham, and Raleigh. And then we use that data combined with satellite remote sensing data, so NAEP imagery, I love your NAEP image out there, and then also LST from MODIS and also from Landsat to develop high resolution, 10-meter spatial resolution heat stress maps. And thankfully we have this new grant from NASA to really extend this work and to develop much more fine-grained measures of mean radiant temperature, which are actually more accurate than using land surface temperature, which is measuring the heat reflectance from the ground. So the last case study that I want to present is actually on the policy side. So there's been a little bit of discussion of Gen AI and natural language processing. I had a slide from my data science class with a cat meme, because I put a lot of cat memes in my slides to keep students interested. So anyways, in the world that I work in, often you don't have nice quantitative numbers that you can use to evaluate policy. And so text data, so speeches and Twitter, social media data, strategy documents, news articles, policy documents, laws. These are a very rich source of data that now we can apply computational techniques and AI to in order to facilitate understanding of how our cities and states and regions and national governments and companies actually pledging climate action. So we've done some of this unsupervised classification, so this type of clustering, which helps us discover themes and topics. And we found actually that there's a lot of diversity in the ways that different actors are pledging climate action. And then one of the other projects that we're working on is, or that we've developed, is called the Net Zero Tracker, which we've developed a code book to evaluate the credibility of the Forbes 2000 climate actions and also national governments and subnational governments. And we have a scorecard, and we use machine learning to extract a lot of this information, so do the data discovery, discover relevant policy documents, and then be able to classify according to, all right, what year are they pledging? Are they actually reducing emissions? Are they relying on offsets? So these are all questions that we're asking. And then earlier this year when Chat GPT came out and Bard, I think I was fascinated like everybody else here And I thought this is really going to be a game-changing technology to help enhance our understanding of very esoteric climate policy topics like net zero. I mean, that's like very diverse, and there are many ways to define it. And so we launched at the end of September chatnetzero.ai, which is the first fine-tuned large language model to help demystify decarbonization and really take aim at potential greenwashing. So I had these slides where you can compare the different outputs. So for example, if you ask ChatNetZero, can you continue to use fossil fuels and still pledge net zero credibly? Which 2/3 of Americans think that you still can, according to a Pew poll. ChatNetZero says absolutely not. ChatGPT says yes, you can. There's another project called Chat Climate, and it just gives you a bunch of garbage because it's pulling from the IPCC data. So I think this is a really potentially powerful tool to help us really understand and interact with data. And on this panel, we talked about magic wands. If you could wave a magic wand, and some people talked about making remote sensing data more accessible. And I think there's a lot of potential to incorporate large language models with remote sensing data to help ease that pace of and the ability to actually analyze a lot of this data. So thank you so much.